Let's start. For a Friday afternoon, yeah. Yes, well, so welcome everybody to a thrilling finish to IETF 117. Thank you for sticking around for this Friday afternoon EMU session. I'm Peter Yee, and sitting next to me is Joe Salloway. So we will get underway. Please note this session is being recorded. That shouldn't come as a surprise. All right, this is our traditional note well. So it's a reminder of many of our policies and code of conduct, things like patents. There are links if you get the official slides as opposed to the video version, and you should be able to click through and read through those. And we have a note really well, so I will read that for you. IETF meetings, virtual meetings, and mailing lists are intended for professional collaboration and networking as defined in RFC 7154 and our anti-harassment policy and procedures in 7776. If you have any concerns, please raise them with the Ombuds team. I won't read through the rest of it, but be nice. All right, so if you are in the room, please either use, I think there's a virtual blue sheet up front. You can scan over here on the screen to the right and sign in using the on-site tool. That will help us to keep track of everybody who's participating. And our agenda. So first things first, we need someone to take notes. This doesn't need to be extensive. I don't think this is going to be a long session, but we do need somebody to keep track of what happens. Any volunteers? Thank you, Charles. All right, and the links here, if you're actually looking at the online versions, take you to the chat, the Meet Echo video, and the on-site tool. You should, of course, be already aware of those. So we have about, I'll say 35 minutes of materials. As you can see, we'll be having 3 presentations, TEEP version 1, Bootstrap TLS, and an update on EAP, aka Prime forward secrecy. Are there any changes to the agenda at this time? All right. Then Alan, I believe you are up.
All right. 7170 is almost done. Go to the next slide. Minor changes since the last meeting, some more diagrams from Elliot. Now that TLS, so now that the TLS 1.3 for EAP and PEEP and TTLS are done, we can reference 9427. There's another error added, inner method not supported, so that you can have some signaling. When the server says, please do X, you now have a bit better error message for saying, no, I can't do that. Because what Windows does, Windows instead sends an empty EAP identity. And then the whole EAP stack goes, what the hell is this stuff, and complains. Based on other discussions, the other EAP methods allow selection of EAP types based on the identity, which you get before you select the EAP types. Turns out you don't do that with TEEP. So we added the identity hint that the supplicant sends to the server, goes, hey, I think I might be Bob, and at which point you can go password or EAP or whatever. Again, nothing implements that, but it's not that difficult to do. And based on discussions on the list, PKCS is not implemented. Might as well leave it in. I don't think that will cause any issues. The next slide. It is possible to use TEEP with inner methods that do not provide the MSK. And the discussion was eventually just add at least one inner method which does provide the MSK. Otherwise, you don't have any crypto binding. Dan.
Yeah, Dan Harkins. So regarding the previous slide, please do keep the PKCS stuff in there. As the next presentation will show, it is going to be used.
Yeah, the conclusion was we understood what it was all about. It's just no one cared to write the code, and it looked like it should work. So there's no benefit to taking it out. Yeah. Okay. So yes, this was sort of a late addition of it was possible in TEEP to do inner passwords, and now you have all the man in the middle attacks, and that's probably bad. And all we can do is really make people aware of this and move on with their lives. Next slide. Based on some discussions with Elliot, there was text in there saying, don't devolve back to EAP-TLS. If you're just going to use client certificates, use EAP-TLS. And Elliot's point was that, well, if you're doing provisioning inside the tunnel with client certificates, you might as well allow those client certificates to be used in TEEP, because that doesn't really make any sense otherwise. And then looking at that in detail for what that meant, I went and updated the text to say, oh, by the way, yes, if you do a client certificate outside the tunnel, you still have to proceed to phase 2 for the inner crypto binding result, et cetera, which also serves as the protected success indication, which we spent a long time arguing about for EAP-TLS and resumption. Next slide. I think that's it. Oh. Implementation issues. I've had some preliminary customers try to do this. It's fun. The biggest thing is if both ends are configured the same, everything works and it's all great. Given that you have no standard way to configure the supplicant, you really have no way to know that both ends are configured the same. And when the server wants to do user plus machine and the machine doesn't have machine credentials, you get things like EAP identities with no links and no error message. And so you have to sort of squint at the packet and go, oh, that's the situation where the supplicant doesn't do the right thing, which then means that it doesn't have the machine credentials, but there's no error for that. It would be better to recommend some kind of automated configuration, which people have worked on for decades and made very, very little progress on for supplicants. So I suspect it will have teething problems in deployment. People will try using it, and if it works, it's great. And if it doesn't, there's endless fights over getting it configured. Next one, I think that's it. Yes. I don't think there's anything else to do. Alex pointed out that some of the diagrams were a little mangled in the latest revision, and that's just fixing the markdown. Any last minute comments, bombs?
No bombs. Just one thing is that I did go through and put resolutions for all the errata in one issue thread in GitHub, and it would probably be good if somebody else took a look at them. I mean, it looks pretty good. My main thing was just to go through the document and make sure that the errata was addressed and kind of take what was in the document. For the most part, sometimes it was closer than others to match what was there. And so I think what we'll want to do is, since we have I don't know, 10 or so outstanding errata, we should try to resolve those. So if I get a little bit of confirmation on those, then we can ship them off to the ADs.
Yeah, I'll take a look at that one when I get back. Other than that, I think it's mostly done. And again, I suspect once people start deploying it, there will be other work to do, to put it politely. Heike?
Hello. Can you hear me?
Yeah.
Okay, good. Just sort of last minute thought about the devolved ETLS case. If there is authentication with devolved ETLS kind of authentication, should TLS session resumption be allowed, and what does it mean, and does it cause any kind of problem, issue, or unknown unspecified behavior?
For what with session resumption?
Yeah,
We
so
had. Yeah, I'll talk a bit more about that. This is one of the discussions we had with EAP TLS itself for 1.3, which was if you have 4 TLS based EAP types, there's nothing really stopping you from doing EAP TLS and then trying to resume with EAP TTLS. Everything will probably work. The same thing for TEAP. So the devolving to EAP TLS was originally based on Bernard's comment of if you're just going to use client certificates, don't use TEAP, use EAP TLS, which makes sense until you realize that the PKCS stuff is issuing the client certificate over TEAP, which probably means you want to use TEAP for authenticating with the client certificate. And then session resumption is just session resumption, and it shouldn't matter. And then, yes, the session resumption for TEAP, maybe this is what you're getting at. The session resumption for TEAP has to use the protected success indicator from 9427, because all the TLS-based EAP types are defined to use that now. So does that address your point, or was that something else?
yeah, I was just thinking that if there is no inner authentication, it just does what's required there on the slides, crypto binding and
Yes,
so on.
if there's no inner authentication, it still has to do phase 2 with crypto binding, et cetera, et cetera.
Yeah,
and that does serve as the protected success indication.
yeah, and then I just log out, for example, and then do session resumption with this kind of previous authentication that was based on this devolved EAP TLS case. So I mean, can I do that, and should I be allowed to do that, or is this some kind of special case for authentication?
No,
in
you
that
should
sense?
be able to do. You should be able to
Okay.
do session resumption. So you authenticate
Yeah.
with the client certificate. When
Yeah.
you do the full authentication, you do crypto binding, et cetera. When you do
Okay.
session resumption, you don't, and you just send that 1 byte of 0 as per 9427.
Yeah, I can see that the protocol allows it, but I was just thinking, is it some kind of special case that shouldn't be allowed? But I guess not.
I'll
So
have
this
to
is
double
okay.
check. It's
Yeah.
been a while since I looked at that. I believe
Okay.
it does say do what 9427 says, but
Okay.
if it doesn't, I can update it and say when you're doing resumption, you only go to phase 2 if you're doing the full authentication. And if you're not doing the full authentication, then you use the 1 byte protected success indication.
Yeah.
And you move on with
Yeah.
your life.
Yeah. Okay. Thanks.
There, one more.
Just me, Alex. Hi, Alex speaking. Backing on to what Heike said, I'm trying to remember, did we deny cross resumption? Imagine you're doing TTLS or PEEP, and then you suddenly come in saying TEEP, but using the same TLS session.
I believe 9427 forbids that.
Oh, okay.
Yeah, that was a point that was discussed, and it was like, again, it probably works. We don't know what it means. It's better to say don't do that than to allow it. Okay. One more. Hecky. Yes.
Yeah, I think that it's like you said, that was said here, that it's not allowed to use one EAP method and then do resumption with another one, because I'd say that there might be some kind of access policies that depend on the EAP method. So if you cross over, then you are breaking the policy, for example, depending on the site configuration.
Yeah, I mean, on one hand, on a technical side, the only difference between resumption for TTLS or EAP TLS or PEEP is one byte in the EAP header, really. And so it shouldn't make any difference, but if we don't know exactly what it means or why people would do it, it's better to forbid it. I believe, yeah, I think either 9427 or 9190 forbids it. Okay. Done, ship it.
Okay, yeah. So I think there are a couple things maybe to check on. It may not require a document update, but let us know, and we'll start a final last call.
I will double check. I'll issue a new document next week, fixing some of the formatting things.
Okay.
Double checking this, and then yeah, next week we should be ready for yet another last call. This time, hopefully, the last call.
Yeah, I think it's getting pretty stable, so I think we should be good.
Okay, thank you.
Okay, thank you. I'm Dan Harkins, and this is Bootstrap TLS, also known as TLS POK, P-O-K. Next slide, please. So this solves the onboarding catch-22 where you need a credential to get on the network, but you need to get on the network to get a credential. It specifically solves this for wired devices that have limited or no user interface. And it does it by leveraging what the device provisioning profile developed for bootstrapping public keys, and uses DPP bootstrapping methods and the elliptic curve public key pair that the DPP defined. It does mutual authentication between the client and the server who knows the client's bootstrap key. And we do this without changing TLS or defining any new key exchanges or funky crypto. We just use 4 existing RFCs in a new and wonderful way. Next slide, please. A few changes to make 03. This was basically comments from Hannes. He noted that we had an unnecessary HKDF derivation to derive the EPSK. So we got rid of that. We had a bad reference, and we cleaned up some language that Hannes found a little bit confusing. So that's basically that's it. Next slide, please. So the new EPSK derivation is, it was noted that 9258 already does an HKDF with the base key, so we don't need to do that again. We can just have the base key be the dir encoded subject public key info of the bootstrap key, and let 9258 produce the EPSK out of that. And then we just create the import.identity struct the way it defines, and we got rid of that extraneous HKDF calculation. Next slide, please. So this is basically how it looks. We're using all of these RFCs to plug in this new stuff in the TLS exchange. The boldface stuff is new for TLS POK, and the non-bold is just the existing TLS exchange. So we're basically doing client certs with external PSK, and the client cert is a raw public key, and we're deriving a PSK with that raw public key as well to authenticate the exchange. And then the exchange is also signed by both the client and the server, and it all finishes up and everyone's happy. So next slide, please. And this is how it works with TEEP. So the client is going to say his identity is TLS POK at eepdpp.arpa to indicate that he's wants to do TLS POK authentication, and then they will do TLS POK authentication, which we just saw on the previous slide, and then do the PKCS. And this is why we need the PKCS stuff to stay in 7170 BIS, because this will allow the client to then obtain a certificate and stop doing TLS POK out for subsequent connections. So he does this one time, he gets a certificate, and then subsequent connections to the network, he can use the certificate that he got with the PKCS exchange. So next slide, please. So this is a pretty stable, we did clean up some language that Hannes had suggested, and we did get rid of an extraneous derivation, but the whole protocol is pretty stable. It's been looked at by the TLS mandarins, and they didn't have any problem with it. So I'm hoping we can proceed to a working group last call. Alan.
If we can go back to the previous slide, my one minor nit, given that there's a bunch of stuff now, starting off with EAP-NUB, with eep.arpa, do we want to say there's an eep.arpa domain and then various sub things inside of that, just to say, hey, this isn't the DPP thing, it's maybe dpp.eep.arpa. It's a nit, but if we're doing, I mean, if EAP-NUB does it, I think there are other proposals to do it. It might be good to have an explicit hierarchy rather than a flat list.
That would probably keep IANA from bugging everybody like they're bugging us when you put this stuff in the draft. They go, oh, you know, how do you want to use this? That's actually not a bad idea, but I don't think that that's something that I'm not sure who would be the person to create this.
You'd still need a registry, right? You just define eep.arpa.
Oh, yeah, but I'm saying I don't think that this draft is the thing that should be defining that registry.
Why not?
The .arpa there is owned by the IAB. You'd have to ask them.
Okay. We're just doing the same thing that EAP-NUB did. So yeah. So I'm hoping that there's a trail that we're gonna follow that trail that they blazed.
The original suggestion to use .arpa for EAP-NUB did come from me because it really was about the only thing that made sense. You couldn't use another domain. ARPA was used for other things, and it's sort of smelly and stinky, but it's okay. My point is, if you just define one eep.arpa, then whatever's within the context of EAP, perhaps the IAB cares less about. Yes. I will delegate that to other people. It's just for me.
Hopefully not to me.
If we have if we have a bunch of stuff under EAP, it makes a bit more sense to have a hierarchy than polluting .arpa with a million different things.
Okay, so
I mean, I think so. Did you get pushback already on this, or for EDPP?
No.
Oh, okay.
IANA just we got a note from them saying, can you please tell us how you intend on using this, and what do you know, they're wondering if this be in the DNS or something like that. I mean, they have really no idea what this innocuous little use is. But
I mean, we could ask the IAB if it would be better to since they own that. But
is that something that the chairs of the working group could do?
The chairs could do that. Yeah.
Okay. Excellent.
So we'll do that.
Perfect.
And then I think we can go last call too. So
excellent. Okay.
I mean, we'll probably try to get some resolution to that before last call, and that'll give us a chance to get TEEP out of the way too.
Okay.
Yeah.
One more comment from Alan.
So this is Alan again. I guess the question is, if we don't use .arpa, what do we use? Right? And the answer, and I don't know that there's any other top level domain that we could use that's defined, that's both short.
Well known.
Example.
There's
no good answer to any of this.
Yeah.
No, I think, so we'll work with the working group to come up with what the question should be. But I mean, I guess for me, using .arpa is fine. It just, do we want to structure the namespace is what I think. But we ought to ask the general question of like, this is what has been done in the past, and
Yeah. Okay. All right. Thank you.
Yeah. Thanks, Dan. I think you're up, Yari.
All right, so I will take you through the changes in the forward secrecy draft for EAP aka Prime. And the sort of the high level status is that it's been revised after many very good comments and discussions on the list, IETF last call, working group, AD. And we did the revision. The document is now in the second IETF last call, which ends Tuesday next week, I believe. And the changes, if you look at the document as such, you will see a fairly large number of changes. Most of that is editorial, however. So one of the authors did a fairly extensive editorial pass, trying to improve the document, say things only once in the document, for instance. Made it better, I think. We also updated some of the references, corrected some of the terminology, aligned the terminology better across the document, and included some additional links on some things. Yeah, and in addition to that, we did a few extra things. We explained the difference. We're referring to EAP aka and sort of added the explanation for that. We talked about how the ephemeral key exchange provides improvements in terms of defenses against pervasive monitoring, and that's for instance the fact that you are forcing some attackers to be active and man in the middle, and that of course raises the cost of large-scale attacks and risks of detection. So that's good from this perspective. We talked about in the document now about whether the forward secrecy property applies to the exchange itself. So we have some mechanisms to protect or encrypt things while the AKA procedure is going on, and we'll have a slide about that in a second. Let's see, did we have any other things? Yeah, we also added a section that's not listed here, but there's a new small section that explains the sort of the implementation and system level implications of forward secrets, that you actually have to be able to remove key material, that if the protocols are fine, but your system keeps the key material in some place where attackers can get to it, then that's not going to be very, very useful. That of course applies to the particular parties that are running this protocol, but it might also apply to parties that transport key material. That might happen in EAP. So it's just sort of a clarification that what some of these properties, in order to actually get them, what that implies. Maybe next slide. So the one bigger issue that was raised was about we have these keys, key anchor and key authentication, and whether they actually get the same protection as we're trying to get for the rest, for the traffic protection keys and so forth, or MSK and so on. And for this key auth, that's just used to authenticate the exchange, the keys. So that's no issue. But key anchor is a potential issue. So just to explain what that's used for. So that's a key that is used internally by EAP aka Prime to transport attributes that are containing encrypted data. So AT anchor can transport sub-attributes that are protected with this key. At the point in the protocol where these keys are formed, the key anchor, we don't yet have the full Diffie-Hellman key. So we're going with something that is not forward secret key. And then the question is, does this matter? And it might matter in one specific case. So the main case that the AT anchor is used for is that you can carry sort of fast re-authentication or pseudonym information. So you're carrying basically like the next authentication identity in some sense in the packet. And if you can get to this, then that breaks linkability. It doesn't give you access to any other keys, obviously, but you would be able to link two authentications together if a compromise of the long-term keys had occurred and then there was an attacker and so on. So we've documented this now. This is the property that this protocol provides. It provides these forward secrecy capable keys as an output, but internally for this one thing that can use encryption, we don't provide that. So that's what the current document does. -11 does this. The authors thought that this is maybe the reasonable path of action, but we could be convinced by the working group to do something else as well. So wanted to get your opinion on this. So one option is that we could recommend that if you actually care about this thing, then don't use these pseudonyms, just do full re-authentication every time. Or one could relatively easily, I think, design an optional exchange where you sort of have some kind of I owe you a pseudonym type of message goes between the parties, and then you do another round trip where you actually have, at that point you have the keys available, and then you could encrypt using something that's forward secret. And so there might be some other options as well, but just wanted to check what people in the room feel that, what do you think we should do? The current thing or something more drastic?
Yes.
Russ Housley. Hi, Ari. I just want to make sure I understand what you said. And what it sounds like is if you were to use this key at that moment, as opposed to do the I owe you a pseudonym, that it's kind of like TLS resumption, that you're just not getting all the protections on those first packets. But if you wait, you'll get the protection later. Am I understanding properly?
I think the answer is no. That's not what's happening, because if you actually are, like, you're early in the exchange, right? So you don't have the full key yet.
Right.
You have the less capable key, and if you use that to transport some information, and then if there was an actual compromise of the long-term keys and so on, then you could get into a situation where the attacker gets this transported information, and that's what I meant with this, that you can break linkability. So you can't fix it afterwards. That's what I'm trying to say, that if you want to protect against this, then you have to wait one round trip, basically.
In the same way, what I'm saying is, in TLS, when you're doing resumption, early data is replayable. But if you sent it after the handshake completed, it would not be replayable. Is it similar to that?
In that sense, it's similar, yes.
Yeah,
so,
okay.
But the only sort of question here is that, do we have the mechanics to send either now or a little bit later? So that's the only detail.
Thank you.
So Russ, did you have an opinion on what we should do then, given this discussion?
I would do exactly what TLS did and document what the ramifications are if you use it, and leave the protocol alone.
So the question was if this was what we did. I think that's what we did, with one caveat that so in TLS, and I'm not the TLS expert, so the mechanisms exist, so the ways to send stuff later exist, and I think for this case we would have to describe those mechanisms, which you could do in another document, for instance, but it might not exist today. Well, that's my understanding. It doesn't exist.
Yeah, that was my question. Was we don't have that mechanism defined in AKA yet, and so is that okay? Do we need to define it in this document, or as you already said, we could defer it and say, well, it doesn't exist yet. That's future work, and If there's desire to do that from 3GPP or somewhere, then we could do that. So the solution as it stands has a gap, right, potentially. But the question is that a practical problem or not? I don't know that we know yet.
Just to follow up a little bit on that. So it is my understanding that this could be done as an extension later. It seems feasible. I haven't done the work, but it seems eminently feasible. So that's clearly an option. The authors did choose to do this version without building support for that and just documenting the issue. My gut feeling is that because this doesn't result in the traffic protection keys or MSK or any of the other stuff from leaking, that's not serious enough to cause us to have to do an update. But we could do, like, the authors would be very happy to do that if the working group wishes. And I want to remind people also that there was another option between these two extremes that do the full thing, just document. You could also say that if you care about this, then don't do the pseudonyms.
So I'm not in the line. I'm sorry.
Just introduce yourself.
I'm Deb Cooley. So I've not read the draft. I've only listened to the presentation. So you're just losing forward security for a little bit of time? That sounds like, I mean, that's the TLS situation, right?
We're losing forward secrecy for a very specific function in the protocol, which is this passing the pseudonyms. We're not losing it for a little bit of time for anything else.
Oh, I see.
So for
just
one thing only,
pseudonyms.
and kind of like we lose it forever, basically. Or I mean, we're losing it if we don't do something else. Then
right. When I say you lose it for a specific set of time, whatever's covered by that is lost forever, right? But you become perfect forward secure later for everything that's passed after. So whatever's in this space is lost always, right? You don't get it back, right? So that's what he means by you lose forward security here, but then later it's okay. So you're losing perfect forward security on the covering of the pseudonyms. Right. Okay. That's interesting. And do you care? No, that's what he's asking. I'm
do
sorry.
you care? I mean,
I'm sorry.
I'm
sorry.
Yeah, we're sort of.
Yeah. Do you care?
You know,
right?
maybe it would be nice, but you know, like maybe this isn't a huge problem and can be done later. So we're kind of in between. And if the working group has a very strong opinion one way or the other, then we'll do it.
Okay. I now I understand what the problem is. I don't have any answers for you, but I understand what the problem is. Sorry.
Anybody else have an opinion, or shall we?
I guess we're not seeing a strong opinion. I mean, I think to me, the thing here is if we go back and do this, it's going to delay, and who knows how long. I mean, probably not that long, but it will cause a delay, and we'll probably have to rerun some of the process because it'd be a significant change. And I don't know what the pressure, if you guys have any pressure to get this out for 3GPP or anything else, or like. So I guess one question for you would be, how confident are we that we could add this later? And then if we can add this later, what's the trade-off between delaying and to do it now, or getting it out now? You know, is there a time, what sort of time pressure do we have?
So there's no sort of SDO level time deadlines, but we do have some discussions with customers that would like to do this. So, and I mean, this has been going on for some time. So I personally would like to get this done and work on extensions on maybe this thing or post-quantum or, you know, many other things. So I have personally a slight preference for doing what we did in this version and not changing it. That's why the document is like it is. So, but maybe if nobody is screaming for this, then we make it so. I'm relatively confident that we can do this later.
Yeah, I'm not seeing any, at least in the room, that there's strong desire to do this now.
I can post the same question also on the list in case there were. I don't think everybody was in online or in this room. So
yeah, that'd be great.
Thank you.
Well, that brings us to the end of our agenda. Was there anything else, Charles?
Sorry. Yeah, Charles Eckel. Sorry, I just had one question for the notes on the previous draft. I missed. Was that going to go out to? Was that ready to go to IETF last call, or is that a working group last call?
It's already an IETF last call second.
No, not this one, but the second one also.
Oh, you mean Dan's?
Yeah, Dan. Sorry.
That would be a working group last call.
Okay, then I had that right. Okay, thank you.
Alan.
Not really any new business, just a bit of a heads up. Stefan Winter and Jan Fredrik Reichers have been working on something called IETF, which apparently works, and they're planning on presenting it in Prague. And the idea is that you use passkeys for IETF, and then you define that the CAs for IETF are the web CAs. And issues like Warren brought up on Wednesday at the plenary of, I can't connect to the stupid network because I can't configure my supplicant, that mostly just goes away. That's the theory. So you just say, hey, for this SSID, I want to use IETF. What domain? I don't care. It's all web stuff. And if I have an account at that domain, it'll just work. So it seems interesting. It seems to solve the provisioning problem by using the web, which is what everyone else is doing, and not running provisioning over IETF. It's good and bad points, but just for people to be aware that this is coming, I guess.
Okay, thank you. Anyone else? All right, then we're adjourned and see you in Prague.
I saw you on the list. Well, welcome. You came for the best time. You came for the best part. Yeah. Yeah. So how are you doing? Yeah, you still at? Yeah, still at it. Ah, yeah. But yeah, doing open enrollment for still cool. Hand in there, having fun. Yeah. But yeah. Good to see you. Yep. When do you go back? What? I'm very far travel. Yeah. All right.
So I will ping Jan Fred just to see if he's interested in doing a 118 presentation, get it on his radar.
Yeah, it's also good if he can.